Hello, I just wanted to do a leetcode tutorial on this problem. So it's rotate an image. So the description is you are given a n by n 2D matrix representing an image. Now rotate the image by 90 degrees in the clockwise direction. You have to rotate the image in place, which means you have to modify the 2D matrix directly to not allocate another 2D matrix. But I believe we can use a hash map, so we should be fine using a hash map. We can pass it by reference or a copy. It should be fine. So as you can see, this is flipped 90 degrees. So this is the equivalent of if you had a picture and then you flip it 90 degrees, it's essentially the same thing because a picture is just pixel ratios of RGB, red, green, and blue. So these numbers would be like representing each color. That's why they say it's like an image. So this matrix is represented by these vectors. So it's a vector of vectors or an array of an arrays. So each item in the array is an array itself. So this is why they're like grouped together and separated by commas, and also each group is also separated by commas. So it's a group of groups, basically. That's the best way to put it. So it's a group of groups. And these numbers are represented by this matrix here, which is what we're given, and we are expected to turn it into something like this. So we go from 1 to 3 here in the first row. That becomes the first column. I'm sorry, the last column. And then like that for every single one. Then we can go ahead and start it. Like I said, I'm gonna use an unordered map for this and just keep a counter of what I'm storing in that map. So an unordered map takes a key. So the key is gonna be an integer, and the value associated with that key is actually gonna be a vector of integers. And we're just gonna name this M for map. Then we're gonna do counter is equal to 0. Then we can go ahead and do size. And we can use size and just exploit the fact that it's n by n. So the rows are the same as the columns. So if it weren't the same amount, so if it were like 4 rows and 3 columns, then we would have to just keep track of that extra check. So now we're going to go ahead and fill the unordered map. So we're going to say x in matrix. So here x is representing each vector in the vector of vectors. So it would represent like all of these. That's 1x. I'm going to say m at counter is going to be equal to x. And we can increment counter. And then once we're done with this, we're going to have counter's going to have one more. It's going to have the right count starting from 1, but it's going to have one more in terms of indices, and I'm going to use it as an index. So I'm going to say, well, I'll see. I might not use it as an index. I'm not sure yet, but I probably should use it as an index. And create another for loop. I'm going to say int z is equal to 0, and the same thing basically. But this time we should no, actually, int z should be I. Should start at I. Because what I'm going to end up doing is doing this. So you see 741 here. So that's my goal, to get the first one going and then worry about the rest. So we have 741, which is the first item in every list. So all I have to do is use my map, since I have them separated by the index. So that way I don't have to mess with matrix, because if I do it in matrix and start changing things around, then start changing values, then values may not be what I expect them to be later in the next iteration. So that's the reason I'm not using matrix just like that, or using a copy of it. I'd rather just use the map. And actually, we're not going to pass this by reference for now. I might change that later. And I'm just going to take the first item, the first item, the first item, and put them all in order, starting from the end to the beginning. And then I'm going to go ahead and start from the next one. So then it's 8, 5, 2, and 9, 4. I'm sorry, 9, 6, 3. And that should work for us to our advantage. So to do that, we're going to create a local variable, call it C for a counter. This is going to be equal to counter -1. Yeah, so we're going to end up using it as an index after all, basically. And then nothing outside the loop. Yeah. Okay. And yeah, we're going to take advantage of the fact that it's an n by n matrix. And we can also use size here and also increment z. And that should be fine. And we're going to say matrix at I and z. So this is just the subscript operator where we're going to access the elements. So, for example, in the first iteration, if we say I is 0, then we're going to this one, and then we say z, which is also 0. So it'd be like, for example, 1. So what we're going to do is overwrite that value with what we have what we're going to get from our matrix. And in this loop, only z is going to change. After this executes, then we'll go on to the next I, and z starts from 0 again until it reaches size. So we're going to say m at to check for bounds. So we want to access the counter here, since we're starting from the end. And then we have to access the value now. So it's going to be at, this one should be C, I believe. And we're going to add decrement our counter until it's at the 0 mark. I believe that should work. Actually, this should be I. Actually, I confused this one. So I confused C for counter, so I'm going to rename it for clarity. Temp C. Temp. So temp counter, temporary counter. And the reason why this should be I is because we're getting C, which is we're starting it at the value 2, which would be our third item because it's item 0, item 1, and item 2 on the array. Since arrays are 0 based index, you have to start at 0. So for example, for this one the size is 3, but it has indices 0, 1, 2, and we're gonna get the map that has the key 2, and we want the first item in that map. So this is our key 2, and this is the first item. Then the next iteration, we want the key with the value 1, which should be this one, and we want also the first item, which is I, which is 0, is our first item. And then again, we want the key with the value 0 now, since we decrement it again every time we're decrementing. And then we want the first item there as well. So that'll give us 7, 4, 1. And that should work. Okay, I'm just gonna write some comments for clarity. And we should be good, I think. Looks like I have. Oh, right. I changed the name, so I have to change it everywhere. And I believe that should work. Okay. Out of range. Not sure why I'm out of bounds here. Because one of these app functions is throwing this exception here. Okay, I see. It was the Z. It's just a typo. Okay, looks like it works. Let's try again some more tests. And we're all good. Looks like it's pretty fast. So now that we've solved it, we can try different variations, see if we can make it more memory efficient. The best way to make it more memory efficient would be to pass it by reference. That does defeat the purpose of creating the hash map, though, in this case. So we can try doing it again without the hash map. But I mean, it beats 100%. So it's probably fine like that. All right, looks like we're done. So it passes all the tests that we're tested against. So thank you for your time.